Hi there, and welcome back to another Papetti Math YouTube video tutorial, where I'm going to be teaching you, yes you, Algebra 1. And in this lesson, we're going to be given a graph of an absolute value function, and we're going to have to determine the equation based on the information we've learned in Lesson 2 and Lesson 1, both of them combined. We have to combine all of our information now to determine these equations. So, based on your knowledge of shifts, determine the equation of each absolute value graph. Okay, so the first thing we want to look at is our slope of our line. And we want to hope that we see, yes, it's going up 1 over, from the vertex, we go up 1 over 1, up 1 over 1, up 1 over 1. So we're not going to be multiplying our absolute value by anything in this equation. Instead, we're just going to have y equals the absolute value of what? Okay, so now we have to take a look at our vertex. How is our vertex shifted from the point 0, 0? Do we go left or right? Well, we go right. How many units? 1, 2, 3, 4. So we shift right 4 units. And to shift right, we have to subtract inside our absolute value. So we're going to subtract 4 units inside our absolute value because this says to shift it right 4 units, which we've done. But now we also want to shift down 3 units. So how do we shift down? And that's the rule that says to subtract 3 on the outside of the absolute value. So the absolute value equation of this graph is y equals the absolute value of x minus 4 minus 3. Using that same logic, we're going to go on to part B now, where we also have a slope of, let's see, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay, so again, we're not going to be multiplying by anything special. We're just going to have y equals the absolute value of, how do we shift this vertex from the origin to get to here? Well, we have to go left 2 units. So to shift left, we have to add inside our absolute value. So we're going to have x plus 2. Now, after we shift left, we also have to shift down 1, 2, 3, 4, 5 units. So to shift down 5 units, just like in part A, we're going to subtract 5 on the outside. Taking a look at part C, again, the first thing we want to check is our slope. So we're going up 1 over 1 on each of these. That's fine. We have a slope of 1, so it's just going to be y equals the absolute value of x, nothing being multiplied. And now we want to look at how our vertex has been shifted from the origin. And in this case, we have to go right to get to our vertex. How many units? 1, 2, 3 units right. So to shift right, we subtract inside our absolute value. And then we have to move our vertex we have to move that point up 2 units to get to our vertex. So we're going to shift up 2, and to shift an absolute value graph up, we're going to add 2 on the outside of our absolute value. So this equation is y equals absolute value of x minus 3 plus 2. Let's go to part D. In part D, now we look at something that does have a slope that's something different than 1. So let's look at what our slope is. We're going to go up 2 units over 1, up 2 over 1, up 2 over 1. And going the opposite direction, up 2 over 1, up 2 over 1, up 2 over 1, which means our absolute value equation is going to start off with y equals 2 times the absolute value. Okay, now let's see where our vertex has been shifted from the origin. And it looks like we have to go right 1 unit to get to our vertex. And to shift right, recall that to shift right, we have to subtract inside 1 because we're shifting right 1 unit. But then we go down 1, 2, 3, 4, 5, 6 units. And to shift down, we have to subtract 6 on the outside of the absolute value. Looking at part E, we have a different slope than 1. So we're going to start at our vertex and see what our slope is. It looks like we go up 1 over 3. And then we go up 1 over 3, up 1 over 3, up 1 over 3. So our slope is going to be y equals 1 over 3 times the absolute value of, let's see, well, we have x, and then we have to look at where this vertex was shifted. It looks like it was shifted left 3 units, so that's going to be adding 3 inside to shift left. And then up 1 unit, which means we're going to add 1 on the outside to shift up. And finally, our little challenge question, which was given to you as a bonus in lesson number 1. Let's see if you watched that video by doing this one. But we have an absolute value graph here. Again, let's look at our slope. And our slope is down, we could think of it that way, down 1 over 2, down 1 over 2, down 1 over 2. So how do we represent a slope that goes down 1 over 2? And that would be negative 1/2. And the same way over here, down 1 over 2, down 1 over 2, times the absolute value. Now in that bonus section, we said that a negative multiplying by a negative flips the inequality upside down. While all of these open upward, this one opens downward. So we want to include that negative there for that reason as well. So now we have to see where our vertex, because it still does have a vertex, but instead of opening upward from the vertex, it opens downward, which is perfectly fine. So where is this vertex located from the origin? We have to shift 2 units to the right. So to shift right, we subtract inside. So I subtract 2 units inside to shift right. And then I shift down 1, 2, 3 units. And to shift down 3 units, I need to subtract 3 on the outside of the absolute value. So we have the equation y equals negative 1/2 times the absolute value of x minus 2 minus 3. So we have just created equations for 6 of these absolute value graphs. And if this video is helpful in creating these equations based on the graphs, please give it a thumbs up. And you're ready to finish off this lesson with exercise number 4. Thank you for watching.